Hey, welcome back to Global Environment. We're talking about global climate change. We looked at some bits of evidence for global warming related to carbon dioxide and methane last time. But we need more of a toolkit to really see if warming is occurring. Now, ground surface temperature data has only been around for about 150 years or so. We need something that can go back further, and maybe in more ways. Now, what is that maybe? Is there something available? Well, we can use paleoclimatology. So think of it. Paleo, is one of the roots, meaning ancient, and climate. So there are methods, scientific methods we can use to look farther back to determine temperatures and also things like CO2 concentrations back in history quite a ways. Okay, so paleoclimatology, we're reconstructing old climate, getting data from other sources, and it's an advantage on our basic thermometer and rain gauges. Okay, what can we use? We can use things like ice cores. We can find ice samples that are hundreds of thousands of years old, and we can get those little bubbles out of the ice and look at CO2 concentrations. That's one example. Tree rings can give us an idea of what climate was doing over the course of thousands of years. And you might have seen from other classes, that the width of the band tells you the rain and even temperature of the period at a certain time, and we can date those rings as well. Lake sediments and ocean sediments. We can look, for example, in ocean sediments and look at these little buggers, little critters called forams. And these forams, with the ratios of oxygen isotopes within their shells, can help us get an idea of temperature over time. We can also look at older historical documents as well that recorded, say, in China, 1,000 years ago or thousands of years ago. Okay, using some of this, we can enhance our temperature data. So in this example, we're going back to 1880. We see some patterns of warmth. Okay, let's look at this slide here. This is what we can get when we use a little paleoclimatology. Now we're going back to 1400, and we see some kind of interesting things here. One is sure, temperature changes over time. You see a lot of fluctuation. But we also see that something very special is going on lately. It really helps us to see that clearly. We also see things like the Little Ice Age, which killed off the Greenland Norse that we talked about earlier in the semester. Okay. Now, we can go even farther back. Now, we're looking at 160,000 years ago in this graph. You can see that down here. Now, we're looking at temperature data and also CO2 data. And as you can see, there's a strong correlation between these. The peaks and the valleys match up pretty well. So, the big question is the CO2 causing the temperature change, or is the temperature change causing the CO2? And it doesn't have to be either or. It can be an autocatalytic process. But again, you have to worry, because if we look at the graph again, if we're looking at, basically CO2 levels in the next 100 years or so rising quite a bit, and remember, this graph, has a break off here. This is a huge increase. If it's even autocatalytic, what's going to happen with temperature? That's something really spooky we have to keep in mind. And again, this correlation is pretty strong, and this has been extended even farther back. Okay. You can look at temperature trends, northern and southern hemisphere, which are pretty interesting, and global. Look at the southern hemisphere. It's actually a pretty smooth increase here. The northern hemisphere is a little different. We've actually seen some cooling and then warming trends. And the cooling trends and warming trends really take place during interesting policy decisions. Clean Air Act came in the early 70s, and that's where we see a big increase. And many people believe this decrease was due to pollution, air pollution, particulates in the atmosphere, and the Clean Air Act actually got rid of these particulates in the atmosphere, and the temperature rebounded. So that's one of the side, not benefits, but side effects of the Clean Air Act, that it stopped global dimming, which this was due to. Okay, so we're going to stop right there and come back and talk about some other methods that are used for measuring global climate change and what it could mean for the future. So I'll see you next time.